Hello YouTube, this is Mars 1952. Today I want to talk about the expansion of gas with temperature. A lot of people have been making HHO, and different generators produce HHO at a different temperature, and we're calculating our MMWs without regard to temperature or steam. I'm not going to do much about steam today, but I can help you with temperature. So I looked up this old textbook here, Principles of Chemical Principles, 3rd edition. So in this example here, hopefully you can read this. It's an example about how they calculate the difference of the volume of a sample that was heated from 20 degrees C to 30 degrees C. And they come up with this fairly simple formula here. You can read that. V1 over T1 equals V2 over T2. If you want to read this, you can just go ahead and pause it. You might be able to read that if you set your viewer to high definition. So anyway, I did it out on a piece of paper. It might be easier to see. So we have V1 over T1 equals V2 over T2. And V1 is the temperature of the volume you measured. T1 is the temperature. What did I say? I'll start over again. V1 is the volume of the sample you measured. T1 is the temperature in degrees Kelvin of the sample you measured. V2 is the sample size at a different temperature, and T2 is the different temperature. In this case, we're going to use 25 degrees C as the standard conversion temperature. Now, to convert from centigrade to Kelvin is pretty simple. You just add 273.15 degrees. So, in the example here, we're going to have 1,000 milliliters produced in a minute at 35 degrees C. And we're going to add 273 to it. And that's going to equal the new volume at 25 degrees C. Of course, adding the Kelvin factor. I dropped the 0.15 just for example. Now, this example, 1,000 milliliters, was created using 166.67 watts. That yielded an MMW of 6. Alright, so we take our 1,000 and we divide it by 308, and that equals V2 at 208. And of course those numbers are just the degrees C with Kelvin added, the Kelvin factor added. And then to solve for V2, that's what we want to do here. We want to solve for V2. We want to get rid of this number right here, this 298. And to do that, we multiply through by 298, which is represented by 298 over 1. So we got the first, this half of the equation multiplied by 298, that half of the equation multiplied by 298. And that yields 298,000 over 308, and that's going to equal V2. Now if you divide 298,000 by 308, you get 967.53, and that's our new volume at the lower temperature. If you use the same number of watts as you used before, your new MMW is going to be 5.81. Alright, so that's an easy way to compensate for heat. HHO4Gas made a nice spreadsheet that he's passing around. I hope to get someone to help him convert that into a Google spreadsheet so we can just post it on Google and everybody can get to it. Now, this doesn't consider steam. To get rid of the steam, we have to condense it out or figure out some other way to measure it. Alright, so here is my homemade flow meter made out of a couple bottles. You guys all have something similar to this. Now what I did here, it's important to measure the temperature of the gas as you measure the temperature as you're measuring the volume, and you want to get that temperature reading as close to the actual measurement as possible. So I just poked a hole in the tube going to the flow meter, and when you're running a 20-second test, the gas inside here isn't going to have a whole lot of time to change temperature, so that's going to be reasonably accurate. So it doesn't do any good to measure the brick that's for other reasons. You measure the temperature in your brick. You have to measure the temperature of the actual gas after it's gone through all your bubblers and dryers and all that stuff. So you can see it's pretty cool out here today. We got a Celsius reading of 9 degrees, 8 or 9 degrees. So anyway, if I was doing a test out here today and my bubbler was cold and that gas was going through the bubbler, it would chill it down quite a bit. And I'd be reading at, probably around 10 or 11 degrees C. Now, earlier, if you look at some of my early videos, I did that in the middle of the summer, and it was blisteringly hot right in the middle of the day. It was 95 degrees Fahrenheit. I don't know what that works out to Celsius, but it was hot. So when I measured my gases that day, I'd been running long tests. The gas had been flowing through my bubbler the whole time, so the bubbler was warmed up. The outside air temperature was warm, so my gas volumes were a lot higher. So even though I posted a 5.5 mmW, it was undoubtedly less than that. Like if I did that same test today, who knows what it would be? Probably 4.5 or 4.8. So anyway, that's that. Measure the temperature HHO if you want to be accurate. And also, you've got to strip that steam off of there somehow.